As Ian said, I'm Jason McCreary. You all know me as JMAC, the creator of Laravel Shift. I'm excited to be back at Laracon Online. I think I spoke at the inaugural one, but I missed last year. But I really like these virtual conferences, even though I can't really see the audience. It allows me to kind of add in those extra slides and go through a lot. So let's jump right in. Um, I always like to start off with a little bit of humor, and this is basically the only valid measurement of code quality is WTFs per minute. So with good code, you have a couple WTFs, but with bad code, you're pretty much saying WTF every other line. And whether this is code that you wrote or it was written by a third party or teammates or whatever, you're always going to have a few naturally. And this is just due to learning and growing over time, which is perfectly fine. But we want to try to avoid kind of that bad code scenario. And personally, I believe that these WTFs and this bad code is really the result of over-engineering. So if you went to my Laracon talk a couple years ago, practicing Yagni, it's available on YouTube if you want to check it out, but you'll probably remember this XKCD comic. It was one of my favorite, but basically it kind of emphasizes that whole over-engineering. Someone asks for the salt, and the developer runs off and builds a system to pass all these arbitrary condiments, and this person's just like waiting for the salt. All they needed was the salt, but they built the system to do all these things that they didn't really need, and they justified it with like, oh, well, it'll save you time in the long run. And I think we do that a lot as developers. I know I do that. I'm kind of constantly fighting the urge to do that. And I think DHH sums that up nicely by saying in kind of an interview he actually did on one of the early episodes of Full Stack Radio, a really good episode with DHH. He's been on a few times. I think this was his first, but he says it becomes quite compelling to apply these fancy, ever more complicated patterns, and it works, right? But he says the code isn't better, and by better he means more clear. It's kind of interesting because you can tell even from this single quote that he kind of just has like a disdain for these patterns, right? He just kind of mocks them by calling them fancy and ever more complicated. And he just kind of, you can tell he values something different, right? He values code being clear and not necessarily like fancy. Evan Yu kind of echoes this, the creator of Vue.js. He says that over the years,
oh, 1 second. I don't. There's some confusion on if you're intending to share your screen or not, or if you're just speaking right now.
Oh shit! Did we not share screen? My bad. Let's do that. Yeah,
we're
most of those
at
are
you,
quotes.
and you're a beautiful man, but
thanks, man. Gosh, you had full screen me. Thanks.
There you go.
Can we see it now?
Yeah.
All good. Sorry about that, guys. They were just quotes in the beginning, so yep. We'll kick out with Evan Yu's quote here. We'll just keep going because again, a lot to get through. But basically, again, Evan Yu kind of echoes this quote that basically says, over the years, I've started to prefer this boring, or that code that is boring, but easy to understand. And he kind of talks again, kind of how when he looks at like these smart abstractions in third-party code, it's just painful to understand, especially as an outsider. Like if you didn't author this kind of original fancy code, it's just a bit difficult to kind of get through. So again, just all this kind of wrapped together here that as you kind of move along your development career, you start to realize that the importance of code maybe isn't really these like fancy patterns, right? Maybe that leads to actually this bad code, right? Kent Beck, kind of the godfather of programming, in my opinion, he also mentioned this just to kind of wrap it up. The craft of programming begins with empathy. It's not, the languages or the tools or the algorithms or the data structures. It's more about empathy. And he goes on to kind of talk about what this means in his book, one of my favorite books, Implementation Patterns. And his motivation for writing this better code, for taking the time to write code that is more clear or easy to understand, is that programs are read more than they are written. And if you think about this, this is just like a universal truth within programming. If you think about the code that you write, how much code did you read in the documentation? How many answers did you look at on Stack Overflow or Laracasts, right, to kind of determine the code that you wanted to write? Even if you didn't do any of that, you still read the existing code to determine where to write the new code. So this is just, again, just such a powerful maxim that once you realize this, again, you start to develop things again with that empathy. You start to realize that motivation to make things more clear, because this ratio is 10 to 1, on a good day. It's more likely 100 to 1. And if you're working on like a legacy code base, where you're trying to fix a bug, it might even be 1,000 to 1, reading 1,000 lines of code just to find that one spot to correct and write, a very simple statement. So this is kind of it for me. And to wrap that all up, just kind of for myself here, basically coding with empathy means coding for the reader. And in doing so, we write this better code, which is code that is more clear and it's easy to understand. So I want to get into 10 practices for writing less complex, more readable code. And we're probably going to take the full hour here. So I may speed up and slow down on certain practices. So let's start at the very beginning, which is formatting. And to Kent Beck's point, I don't want to talk about formatting as it relates to spaces versus tabs or K&R versus almond for curly brace placement. It doesn't, that's not necessarily what matters, right? What matters is that the code is what's called visually honest, okay? This is something that comes from Kevlin Hinney, his 7 ineffective coding habits. And what he does to represent this is basically says that he kind of creates what's called a visual representation, and he replaces all syntax characters with the capital X. And this is to avoid our developer brain from like reading the syntax and focusing more on reading kind of this structure or this representation of the code. And this is important because reading is a learned process. Like when we're born, we don't know how to read. We definitely don't know how to read code. So not only are we taught how to read, but then ultimately as programmers, we're ultimately taught how to read code, right? And so because of that, our brain being a very efficient, tool as it is, it uses, heuristics and patterns to try to determine things at an unconscious level, like what's the structure of a sentence? What's the structure of a paragraph? It uses punctuation and spacing. This is why formatting matters, and it's the same for code. So we take a look at this, and it's just visually dishonest. We would really have no clue what this is. Is this a set of 3 statements? What's going on with this code? But by simply formatting it with line breaks, indentation, we can start to see this take an inherent structure, kind of at an unconscious level. We don't know the language or the syntax here, but we could guess that this is some kind of block of code. We can see that by the indentation. We can tell maybe because of those tightly wrapped lines and that spacing up top, maybe this is a method declaration, right? Maybe this is a function call. So we start to get more integrity here. We start to get more visual honesty, as Kevlin Hinney puts it. Let's look at one more example just to drive this home. Again, don't really know what this is. It's kind of visually dishonest, but by introducing line breaks and indentation, again, if we were a live audience, I might have a few people calling out now that this is an if-else block. And that's the point. This is why formatting matters, is because it helps a reader determine, even at an unconscious level, the structure of the code. It just makes it a little bit easier, for our brains to process, right? So here's some actual PHP code, and of course, with the syntax highlighting and the lack of formatting in this case, it's very hard to read. You see things at the top level. We see differences in curly braces. Sometimes they're used, sometimes they're not. We also see, sometimes code's on one line, right? There's no line breaks at all. So it just makes this, again, visually dishonest. This code's not necessarily complex, but it just kind of looks like a mess to a reader coming in. So if we introduce some simple formatting, in this case PSR2, we can get a better understanding of the structure of this code. Now there's more we want to do to this code, and we'll look at those in future practices. But for now, this helps determine visually, again, visually, it's a better representation of what this code does. It's a better representation of the nesting of the logic that's happening inside of this code block. So very simple with formatting. It's kind of like the infomercial, set it and forget it, right? You choose it, you automate it, and you forget about it, and you move on to better things with your programming career. Because if you're wasting your time formatting and spacing out all your declarations, it's just there's better things to be doing. So if you can automate all that, great. But as far as choosing a coding style, Laravel makes it very easy. You just want to use PSR2. PSR2 is kind of the base formatting. There's some other things that Laravel does, like trailing commas and the string concatenation operator. Spacing is a little different. You can still automate all that. There's tools available. PHP Code Sniffer, there's rules for it. I'll make sure to share those in the chat. But again, once you can automate that, whether you do it yourself or you use a tool like Style CI, you can just forget about it and move on. So the next practice is dead code. Dead code really relays to the reader that you just kind of don't care about this code, and it kind of perpetuates this vicious cycle that ultimately rots a code base. Dead code is, in my opinion, the reason that you go from really nice, shiny code to like a legacy, crappy code base nobody wants to work on. So you really have to be diligent in kind of getting rid of dead code as you see it. And it takes a lot of different forms, so let's just kind of go through it at its simplest. It's just commented code. It's just code that's in line. It's a little bit noisy. It looks messy, right? And it also kind of begs the question, as developers, we're very curious creatures. So like, why is address, city, and state no longer being set in data? Why aren't we using the unescaped Unicode flag anymore? So it just kind of is like, why are we doing this? And maybe a new developer might comment this back out, and maybe there's a reason it was commented, right? So the thing to do, the proper thing to do, especially with version control, is just to remove these so they don't clutter up the code. There's also unused code. So in this case, we have an extra parameter. The C parameter is never used. That would be very difficult to see from the outside. Maybe as the original author, we might see it. But if we're just using this code, maybe we pass that in and it never does anything, right? On a local scope, we see that the sum variables, this temporary variables, never used. So it's just, again, as we're hacking along on code, we might have these extra tidbits that get left behind, but you definitely want to make sure to kind of clean up after yourself. I call that Boy Scouting. So just kind of leave it better than you found it. So whether you come across this as a future reader or if you're the original author, just make sure to clean it up. There's tools that can help with this, static analysis. There's PHP mess detection, which will find this if you're working in a legacy code base. If you use PHP Storm, you can run their inspections to find code like this. So it just makes it just a little cleaner, right? Another form of that is dead code. Again, you can run inspections on this. It's a little silly, I know, in this kind of contrived example, but basically when you have multiple return paths, sometimes you may never even reach the code that's below it. And again, right here, it's easy to see, but in a longer block or some chained methods, this is something that might be a little more difficult to see with the naked eye. So again, there's all sorts of detections you can run to find these types of things and remove it. There's unnecessary syntax. This is kind of an interesting one, and it's found in different languages. But the most ready example is the switch statement. If you have returns inside of the different cases, there's really no need for the break. In fact, with the default case, there's never a need for the break statement. So this is just, again, some kind of unnecessary syntax that can just be removed to tidy up the code slightly, especially in a really verbose structure like a switch statement. So just a way to clean some things up there. And then finally, the hardest form to identify in dead code, and even static analysis has a hard time finding this, is flagged code. So what we're talking about here are feature flags. So let's say we had a little system here that had some kind of promotional reward for a user, and if it was toggled for them, then maybe they got some kind of discount. But when that promotion period ends, right, this code's going to be left in here, and it's going to be very hard to determine to remove it because of the nature of it, because of this array input of flags that rewards may be set or not set, or toggle reward feature just no longer runs, it just returns early or something to that effect. So it creates that dead code or that unreachable code. The best way to combat this really, honestly, is just to incorporate in your business process when you have a promotion, make sure you have a task or some checklist or story to go back and kind of clean up this code, because otherwise, again, it'll choke the code from the inside out. So the point here is if you encounter dead code, as whether you're a current reader or the original author, you just want to remove it and tidy it up to leave, from having to be read by future readers and causing confusion, right? Or making the code, again, just look messy. Okay, nested code, getting on to some more important things here. Nested code really forms the building blocks of all code. So what we're talking about here are conditional statements or loops. So let's take a look at this set class. This is kind of akin to a collection object, but a set has the properties of uniqueness. So we only want one of a type of item in there. So just to give you an idea of what we're working with here, we have this isEmpty method inside of our set class. And very briefly, we just have these return raw Boolean values. Anytime you see this, even though these aren't necessarily complex in any way, and arguably they're pretty basic to read for a developer, it's kind of a clue though that you can actually clean this up just a little bit. So if we take a look at that overall block, anytime we're just returning raw Boolean values like true and false, we can just return this expression directly. We basically turn 5 lines of code into 1. Now, I do want to emphasize that the goal of readable code is not necessarily less code. I've seen one-liners that are incredibly complex, right? They're smart to Evan use point. So that's not always one and the same. But in this case, where we have these raw Boolean values and just a very simple if structure, we can return that condition directly, just to tidy it up. So let's take a look at add. Inside of add, we have something that's a little bit interesting. And again, it's kind of laughable, but I've seen this in a lot of code. Empty if blocks. And this is either the result of removing the block over time because of functionality changes, or maybe, excuse me, or maybe a new developer that maybe they just kind of think in a positive tone, right? So they check for the positive thing, but really they need to do the opposite of that thing. So they put all the body in the block. So we can clean that up by just inverting the logic. So we turn that is equal to null to not equal to null. Now we can pack it down. It allows us to see that nested code a little better. So anytime you have nested ifs stacked on top of each other with nothing else going on, you can collapse those with an and. So again, we get this a little bit tighter. And some people might leave the code right here, but I actually don't like this because what it does is it hides what I call the primary action of the code. So in an add method of the set, I would expect to see that we're adding something to our internal items array, right? But it's kind of nested here, and I don't like that because I don't think that calls out, again, that primary action for a future reader. So what I like to do is make sure that my primary actions are at the top level. It's just kind of a rule that I have. So when I bring that out, I can effectively invert that condition. And what I do is that allows me to early return from that, but then draw out that items addition at the top level. And what that becomes is what's called a guard clause. And I like these because they do a good job of communicating what the exceptional states are. So when I come into the add method as a reader, I can instantly see that if my item that I'm kind of coming in with and tracking is null, or it's already within this set, that I'm just gonna skip out of here. I'm not gonna perform the primary action. So I just think it reads pretty nicely. All right, let's take a look at contains. This really is just gonna build a little muscle memory. So this is the combination of both here. So what we see are those raw Boolean values. We see those nested stacked if statements. So we're gonna go ahead and pack those down with that and like we talked about earlier. In doing so, we can kind of tell that these conditions really kind of share responsibility in a way. The not is empty and then checking if something's in an array, we're really not gaining anything out of those two, right? You might consider it a micro optimization if you're dealing with a very large set, but I would imagine that in array itself has some kind of built-in optimizations for an empty array to return early. So because of that, let's just drop this is empty statement out of here. Oh, froze up a little bit there. So let's just drop this is empty out of there. It packs it down to a single condition, and we know what to do with a single condition. We can just return that directly. So that's contains, that's our whole set class. And what this boils down to, you can think of it as avoiding else. And this is something that I heard from Raphael Dams at a PHP conference a couple of years ago. He gave a talk on code katas. And these code katas were basically just, again, kind of practices that you could do. So I think avoiding else is a good start, but I really like to call this avoiding nested code. We focused particularly here on kind of conditional statements, but if you have code that has a lot of loops, you could definitely look into the collection class inside of Laravel. Excuse me. Adam Wathan has a book, Refactoring to Collections, which will do a great job of kind of helping you clean up that code so it's not as nested like we saw here. So definitely check those out if you're dealing with a lot of loops. All right, let's move on to the next practice, using objects. This really focuses on our primitive obsession. So primitive obsession is basically where we use our scalar types or these primitive types. In this case, we're going to pass in a float amount and a string of currency. And what you'll notice is that this pair of data or this set of data forms what's called a data clump or a data group. And you'll see that we kind of pass the same set of parameters around over and over and over and over again. And instead, what we can do is we can formalize the relationship or the coupling between those two sets of data into an object. So we want to do that, and that's going to be just simply a money object, right? And it's going to hold the amount and the currency. And we notice that when we do that, we not only have a nice symmetry between our now all object parameters, but we notice too that that gets passed down to all these internal methods, right, that deal within the system of transferring money to and from accounts. So it just kind of cleans it up and tidies it up better and formalizes, again, that coupling and gives us a nice home to put those pieces of data to represent a larger data object. So taking a look at this money class just quickly, we see that those properties are there. We see the getters for it, but notice that there aren't any setters. What's very interesting is with objects like this, they're often value objects, and as such, they can often be immutable, which is a great practice to follow because it gets rid of a lot of state that's internal to an object. And that gets rid of a lot of conditions and nested code and all the things we talked about already. So it just makes the code a bit tighter and a bit cleaner. So now if you need to transfer money or convert money or do something, let's say we're going from US dollars to euros, we introduce an object that now maybe converts, and it's a brand new object, right? We're not taking the same one and just adjusting the amounts and the currencies in its internal state. We're just creating a new object to pass around. So this never changes. So that immutability is a very strong paradigm within programming that this all kind of lends to when you use objects. Another benefit of using objects, again, we'll see a data clump here in this kind of limiting function. It just accumulates different numbers based on a min and max value. We see that logic scattered here. This is probably elsewhere in the application. So the emphasis here to use an object is not necessarily just that coupling of the data with the range into a range value object, but also the fact that objects give us a place to encapsulate that logic. So now we can kind of tidy that up in a nicely named method, which is includes. We can hide that logic of greater than or equal to, the min value and less than or equal to the max value, and all sorts of logic that might, again, be copied around the code. So it gives us a home for that as well, which is nice too from a readability perspective because it dictates ownership, it kind of documents and hides some of that or abstracts some of that complexity. All right, finally, another one to revisit is kind of that flag stuff we looked at before. This is actually very close to a method that's inside the router class in Laravel. And what it does is it passes in that kind of dreaded options array. And this is fine for just a couple things, but it's really abused in the PHP community at large. And the issue with this is that this options array has no formality to it. There's no structure to it. I could pass in really like whatever I want. And over time, as we saw with dead code, this might lead to some oddities, right? Even though it's probably the underlying code is obviously not going to do anything malicious necessarily, it's just a bit untidy, right? It's a bit confusing, especially to new readers. Well, what are all the options, right? And without those being properly documented or something, it could be a bit interesting. So what you can do instead is instead of leaping maybe to a completely new object, we can use kind of an in-between object, which I consider an enum. And what this enum is basically this auth option. And what it allows me to do is create constants within that class that formalize all the different auth options that are available. So whether it's verify or register, excuse me, or whether it's register, it allows me to, again, formalize that structure without having to really create a verbose syntax of newing up an auth object where we pass in all these different properties. So this enum allows me to do that. And the logic inside is relatively the same level of complexity. Instead of the null coalesce operator, we have a bitwise operator here to see if that flag is toggled on this integer of flags. While this might not be super popular in Laravel, it is popular in the underlying Symfony framework, which Laravel is built on top of, and it's very popular inside of PHP, which is a C-based language. We saw that actually earlier with that commented unescaped Unicode for the JSON encode options. So it's used, it's popular. It's something that could be that stopgap where you're still using an object to help with the formalization, but you're not going so far to, kind of have to new one up and maybe noisy up your code arguably with a brand new object. Okay, let's talk about big blocks. Big blocks are basically long methods of code. So this happens a lot throughout the code base. Let's take a look at a couple Laravel examples here. So we have this enrollment controller, and this is the store action on that controller. So basically it's going to enroll a user in a particular course. So let's take a look at this method. So it's relatively long here. And let's just kind of go line by line. Whenever I come across a long method, I just kind of start breaking it up into its kind of sub blocks, if you will. So the first big block that we come across is basically this validation code. Now, validation is very easy to do inside the controller on the request object, or you can make a new validator object. But because this actually accounts for, let's say, a quarter of the big block here, it just might have a better place somewhere else. The reason I like to move these larger validation blocks elsewhere is because the controller to me is a very high level object. And at a high level, when I come into a high level object, I expect to read things at a high level. So when I come into a controller, I want to read things that are kind of business logic-esque. I don't want to get into the nitty-gritty details of what it means to store an object in the database, what it means to validate an object. I kind of just want to see what the action is doing, what the store action is doing. So I can take this validation object, which I consider low level compared to the controller, and I can move it into a form request object. So that allows us to just take that code, copy it over there, let the framework do all of that logic for us. It just cleans us up, gets rid again of a quarter of the big block of code here. Similarly, even though it's just one line, we can again leverage the framework. We don't have to write any of our own code. We can use implicit model binding to bring in that course object. It's going to do the same thing. So now we actually get to the meat of this big block. And this big block starts with this if condition. It's not necessarily a guard clause because if we take a look at what it's doing, we see that there's common code paths between these. So again, that primary path that I was mentioning earlier, we see that not only in the if block, but we see it a little bit lower on the screen here with this enroll user. So both of them do that, and both of them ultimately redirect to the course page. So what I want to do is I want to draw that out again to the top level. And I'm going to share that code by introducing a private method to handle this kind of logical switch. So I'm going to take this, I'm going to pull it out, and I'm going to bring everything back top level. So when I come into my store action, again, I'm reading that business logic. I'm immediately seeing that I'm going to enroll a user, and I'm going to redirect them to the course page. That's the level at which I want to read at here. Okay, again, we want to think about the reader. We want to think about them coming in. It's very easy at that point to take that abstraction of creating a user if unauthenticated. Again, a little bit of a verbose name here, but it's very telling of what's going on. It's very easy for me to command click or control click down into this method and start to understand if I need to. And if I don't, then I just keep reading at a high level. So I get a proper guard clause inside of here. We see that I basically just copied the code from above. Whoops, I get that proper guard clause up top. So if the user's already logged in, I'm just going to return that user off the request object. And then we see that copy code again from above. So now we can kind of tackle this big block of code. I don't necessarily want to read things at a low level, right? I still consider we're in the controller, we're at a low level. So I don't want to see what it means to build or create a user object. I'm going to push that down to the model by making a named constructor. That's going to introduce the coupling between the user model and that element or enrollment request. I'm going to pass that request in. And because of that, I've documented kind of the pairing between that. And it's going to be very easy to pull the data and use the code we just saw down in the model, right? If we move on a little bit more, we see this next line of code is this course organization. Now, I argue anytime you see something like this that you're reaching a little too deep. This is called actually feature envy, which is another code smell that's introduced in Martin Fowler's refactoring. It's kind of one of the original. But anytime you're kind of reaching multiple layers, it probably isn't something you want to do at this level. So notice I'm not even passing in the course to this, so this piece of code wouldn't even work anyways. And it's because I want to move it to the actual courses enroll user method. It already has all the data it needs. It has the user that's being passed in. It's obviously within a course method. So that relationship's going to be a little more clear at that level. So I'm going to drop that out there. And that basically allows us to get to a state where we just have this auth login and we're returning users. So it's nice and tidy. Let's look at one more example here. This is the authenticated callback that happens within the login controller. So once a user's logged in, you can perform some additional actions. In this case, we're going to redirect them to a specific dashboard. So we see a lot of duplicate code here between the roles. We see this, determining if it's an AJAX request. So what I want to do, again, is just kind of break all this up, make it a bit more dynamic, but yet still approachable, still readable, right? Still clear what's going on. So what I want to do, again, is introduce that private method. It's an aptly named private method to redirect to a dashboard. It's going to tell us what's going on. I'm going to leverage the framework to give me that AJAX, so I'm actually able to remove that code. Something you notice probably with the big blocks is it's kind of a shell game. You're normally just moving code from one place to another, right? The only time you can really truly remove code is if there's a native way to do it. And there is in Laravel. We can just get the AJAX property off, or we can call the AJAX method on the request to determine if it is a AJAX request. Similarly, we can push all that logic to determine what the user's dashboard is down to the user. We can just make it a little helper method on the user object or the user class. And that allows us to make this dynamic redirect to dashboard where we similarly, just like before, same logic, we have this early guard clause that if it's a AJAX request, then you're going to do this thing. Otherwise, you're going to return the redirect, the standard web redirect to that dashboard page. And just for completeness, we can see kind of this dashboard method on the user class. Arguably, you could delegate this down onto the role if you really wanted, but that's kind of up to you at that point where this ultimately lands. So for now, it's in the user class. All right, let's talk about naming. Naming things is hard, right? But we can actually make it a little bit easier if we follow just a couple practices. So first of all, dealing with just some really simple low-level stuff here. Anytime you have like standard code, code that's shared or common amongst multiple languages, right? So a for loop. There's really no reason to be a unique snowflake. There's no reason to use X or Y or W or V or anything like that. Just use the standard and traditional I for the loop control variable. That's common again in every language, every hello world, so forth. There's all sorts of examples. That's what they use. Again, it's going to be very familiar to your reader. It's just going to allow them to breeze right through your code without having to think, wait a second, what's that W variable again? So with I, it's pretty easy inside of that structure. Similarly, with for each loops, don't necessarily be lazy. Definitely try to use pairings of plural and singular. Ideally, something that's maybe a little more clear than items and items. Maybe it's people and person. It's attendees and attendee. Something that's specific to that context is good. Similarly, there's really no reason to abbreviate anymore with IDEs and the abundance of memory. We just don't need these, single letter or single character variables. So definitely, write them all out. Auto completion's there to save the day. The fancy refactoring tools that are in something like PHP Storm is very easy to rename these, so it's not that big of a deal. And it's going to be more clear to your readers. And finally, something else that helps is try to turn off your programmer brain, right? And instead of relaying technical aspects, you want to relay human aspects, right? So in this case, instead of saying something like str error or string error, we want to say something like error message. It's pretty similar, again, in our programmer brains, but to a human, one's just a bit softer than the other. One relays just a bit more information. We can, as programmers, pull out the data type that it's a string based on, the right side of that equal sign. It's just going to help later on just kind of read that and be a bit more clear. So take the time, again, to try to relay that human context. So where naming things gets hard are probably for larger objects or higher level objects or names that you use within your application. So a lot of the times, again, we kind of fall back on this technical thing. And I think this is okay to get started. You don't want to make naming things hard by like getting stuck on a name. You don't want to sit there for like an hour and think of a name. So a lot of times I'll start with maybe the technical name, and then I'll allow time to kind of work to my favor. I'll allow meetings and conversations with clients or stand-ups or conversations with a pair developer that maybe we come up with a better name that way organically in like the real world too, which is good. And so by doing that, maybe I come up with a name or an idea for a name. Maybe I take that name and I put it into the thesaurus and I determine other names that are similar until I land on one that makes a little more sense. So maybe instead of something technical like event handler, I actually come across something like an operator. And once I have that nice name that maps better to kind of the real world, maps that domain better, I want to use vocabulary that relates to that name also. So instead of an operator handling or removing events, well, an operator probably connects and disconnects calls. So we can kind of see how once you land on that right name, we get this really nice symmetry, this really great readability that happens if we're thorough and we go through and kind of correct those names. Okay, moving on here, removing comments. This one's a bit controversial. I posted this on R Programming a couple years ago. It was actually, I think, the #1 post for like lunch, but I got a lot of people that reacted this way. They were like, crazy, removing comments, oh my gosh, people hated me. And But what came out of it, I won't necessarily go through the whole blog post that I wrote, but what came out of it was actually a reference to Rob Pike, who wrote an essay, I think, gosh, in the early 80s. This was possibly before I was born, maybe even definitely before I started writing code. But it's a great quote that just comes across all of it that he wrote, again, kind of one of the godfathers of programming very early on. So he says, first, if code is clear, it should explain itself. So kind of this idea that we're playing with here, that if code's clear and readable and boring, to Evan Yu's point, that it's going to be easy to understand. So let's focus on that and not the comment, right? Let's focus on code that explains itself or is easy to read. Second, he says comments aren't checked by the compiler. A misleading comment can be very confusing. So I can't tell you how many times I've come across code where the comment and the line of code that's being executed are in complete contradiction to one another. And when that happens, the bottom line is whether the code's right or wrong, it's what's being run, not the comment. The comment can be right, and state what the code's doing, but if the code's doing something else, at the end of the day, that's what's happening. That's what the compiler cares about. So we want to focus again on the code. It's the primary signal. Anything else, honestly, is just noise. So to that point, and to his final point, it's the issue of typography. He says, comments clutter code. This is exactly what we're talking about. From a readability perspective, we've almost trained ourselves as programmers to just skip over comments. We don't even see them. In fact, the highlighting that they receive in most editors is much, much more muted. It's just not something we look at. So because of that, we want to attempt to eliminate, we want to challenge ourselves to eliminate these comments to improve the code in better ways instead of writing the comment. So before we get to the example, let me just say that doc blocks are not comments. Doc blocks, even though they are syntactically comments, are documentation, especially something like the Laravel framework or any framework or popularly shared library. These serve a much higher purpose than the comments that we're going to talk about here in the code sample. So just to be clear, I'm not saying go in and remove all of the doc blocks. Those are documentation. They serve the purpose of improving shareability or readability of the code in different ways. They serve the purpose of automating documentation. So because of all that, these are not the comments you are looking for. But the comments you are looking for are inline comments or even multi-line comments that are nested within the code. So let's take a look at this Twitter client here and kind of see how we might be able to get rid of some of those. So let's just kind of scroll down. We see that this is kind of deceivingly long, right? It's again, visually dishonest. It's not really a lot of code here, but for whatever reason, it feels like a lot of code. And maybe some of these comments are worthwhile, but it seems like most of them aren't when we take a look. So let's just kind of go through them. We see right away, we start off with this kind of inline comments that says what this function is going to do, but the name of the function could just be rewritten to incorporate what the comment's ultimately saying. So the comment says get tweets since yesterday for handle. Well, we have a method named recent tweets and handle. We're kind of halfway there, but why not just call that method tweets since yesterday and pass in the handle? So now we've incorporated what the comment did hold value on, which was a clearer name, right into the code, right into the signal, that's going to boost that better than noisy it up with a comment. So moving on to additional comments, we see a lot of these declarative comments. They're comments stating what the code's doing. Again, as programmers, the signal is going to be the strongest. We're going to read that first. So let's ignore these comments. Let's try to get rid of them by just boosting or improving the kind of the quality of the code directly. I had an old boss that actually called these comments the cooking show. So when you have these like really declarative comments where you're like, we're going to store the date for yesterday, and then we're going to set an array to loop over and return values, and we're going to put those in the oven at 350 degrees. It's very, they almost come off a bit condescending in a way. They're too much instruction. We're getting the instruction from the code as programmers again, so these are just a bit silly. The other thing I want to do with these types of comments specifically is a lot of developers have the habit of putting declarations at the top, especially variable declarations or variable assignments where we default them. And I think with PHP, that's because of its C-ish nature. I was actually educated in C. That's what I learned when I was getting my CS degree. So I kind of do this a lot myself. I put all these at the top. But I tend to break that by using and employing what I call the proximity rule. And the proximity rule is basically to take these and move these a little closer to where they're being used. And what that's going to do is boost that context, right? And when we do that, and we bring this down to where this is actually used a little closer to home, if you will, this allows us, again, to not have to worry. There's not as much pressure on, great naming or having these comments, because everything's just nice. And again, in that kind of visual space on our screen, we can kind of see how everything ties together instead of having to remember, oh, when we scroll up or down, that's what that thing was, right? That's what that variable did. So we're still going to focus on improving these a little bit, but that's one step to kind of help. So having these closer together is going to help. But we can also, of course, call this yesterday instead of date. We'll see immediately how that's used in this loop. Now, relatively speaking, this loop is a little bit of a big block of code. So we're going to employ that practice that we learned earlier. We're going to take this relatively complex for each statement. We're going to tidy that off into a nice filter tweets by day. This is clearly a method that's going to be used elsewhere in the Twitter client. We see immediately that we're passing in the tweets that we pulled above. We're passing in that yesterday variable. And now if we look at these 3 lines, the other 2 comments that exist really kind of exemplify this temporary variable, this ridiculously ret value name. We can just straight return that. And so when we do that and we look at everything else, we took this, probably cut it down to a third, took out about 60% of the code, which is basically the comments, and we cleaned up the rest. Now, I will point out that there is one comment left. This comment is important, and I did this on purpose because this comment actually says why the code is using the user timeline endpoint. This is going to be hard to abstract with a name or a private method or something that kind of relays or communicates that to the reader. So this comment actually has some value, and I would leave it because, again, it's saying why something is happening. So just, again, a challenge to try to remove comments. Doc blocks are not comments, and not all comments necessarily need to be removed, especially if they're relaying some kind of important information on why something is being written the way it's written. Okay, let's move on to some of the last here. We're getting close to time. Reasonable returns. So reasonable returns are basically combating null. And so a lot of times in code, when we have kind of this empty state or maybe even this exceptional path, we end up returning null. And that's kind of bad because what it does is it forces higher level code to have to handle null. And this is why the author calls null the billion-dollar mistake. The creator actually claimed that, and it's just because of all the logic bugs, logic mistakes, and extra code that has to be written to kind of handle this null value. So what's a lot more reasonable than returning null is returning some kind of representative empty state. And to determine what that is, we can look at what kind of the happy path would return. So in this case, our little vowels thing that looks at a string and determines the count of the vowels in them, it's going to return an array using the native string split method. So instead of returning null, if we didn't find any vowels, why don't we just return an empty array? Seems pretty straightforward, but this happens a lot in the code where we're returning null. So just reviewing these and looking for better alternatives, better empty values, is going to be a lot more helpful. It's going to be a lot more reasonable. So we'll see here that at the lowest level, instead, we're going to return this empty array. And so what that means at a higher level is that we can actually, take out that entire null check that we have. And because we're returning something that's in line with what that method would return anyways, we can just allow the code to basically play on. And so it just tidies it up a little bit. It gets rid of that nested code. It gets rid of the additional logic. And it's easier to kind of read and follow, again, for future readers. It's less complex. Let's look at another one because a lot of the times, well, what's the alternative to, or what's the empty value or reasonable return for an object, right? Let's say that an object isn't created. So for example, we have this auth user, but what if auth user returns nothing? It returns null, right? So we're gonna have to check for that. And that's fine in our little greetings method here. But again, maybe there are some alternatives. So we could imagine that if auth user didn't return null, maybe it returned some kind of stand-in object, right? Maybe theoretically a mock object. We're familiar with this in testing, but we don't use this a whole lot in kind of our user land or our application code, but it has a lot of benefits. So what if we actually had the user class return a guest object, and this guest object had a bunch of reasonable or default values. So for example, its get preferred name on the guest object would return partner or guest or whatever, right? We can see where this actually starts to have some benefits, not only in removing that nested code, but also allowing the application to kind of work in a way where it doesn't have to manage so much state because of kind of these simple objects or default objects, or again, just mock objects if you want to call them that. Okay, second to last here, rule of 3. This is a little easier with a live audience, but I'll try to play through it. So what I want to do to demonstrate the rule of 3 is basically show a numeric series. So I'm going to give you the first number in the series, and you're going to kind of guess what the next one is. So if I say, here's 2, what's next? Well, it could be a lot of things, right? It could be 4, it could be 3, excuse me, it could be a descending series, so it could be 1, it could be a decimal series, it could be 2.1, right? Or 1.9. We just don't really know. There's infinite possibilities, especially if you're a mathematician. So, but if I give you another number, right? So now we have 2 things in that series, and I say, what's next? Well, we might be able to, you know, kind of more confidently say, okay, well, it's going to be 6, or it's going to be 8, or maybe we get up there with something like 16, right? But the point is, maybe we're feeling a little more confident. We have a little more data points, right, to determine what's next. So I do tell you the third one now, which is 16. And our programmer brains are probably going to go to the right place here. We're going to guess something. Maybe we're going to whip out our calculators, and we determine that the next number is 256. So now that we have the third and the fourth, and we start to have more and more data points, we can tell that this is an exponential series. And we would definitely whip out our calculators now to determine what was next in the series. But that's the rule of 3. The rule of 3 is effectively telling us that as we get more bits of data, we're going to be able to determine kind of what happens next, right? We're going to be better predictors of the future. And this is important because very early on, we're taught about the dry principle. Don't repeat yourself. And so kind of to the whole point of bad code, WTFs, you know, over engineering, a lot of times when we see duplication, we're so quick to abstract it and put it somewhere else. But what ends up happening is we're guessing. We don't have enough data points. So the rule of 3 tells us, hey, wait till, you know, the third, the fourth, the fifth, the ninth time even of seeing that duplication, determining that pattern before you kind of abstract and assume or hypothesize what's next. And Sandy Metz actually sums that up nicely in one of her talks, which she put into a tweet, which is duplication is far cheaper than the wrong abstraction. So if we think about that from kind of a cost-benefit analysis of our code, it's a lot better just to live with the duplication than it is to create some kind of wrong abstraction, some WTF code that we're not going to end up using. It turns into dead code. We have to carry it all that time. We have to read through it all that time. So it's just better to live with the duplication for a couple iterations until you determine the best way to abstract it. And that's the rule of 3. All right, the final practice is symmetry. So symmetry is really what gives us that final touch and final readability on the code. And we've seen it already a little bit in some of the other practices like naming or those big blocks. But let's emphasize it just a bit more because this is really what makes the code that that artisan, you know, gives it that artisan crafty feel, right? So let's look at a excuse me, let's look at a task repository. And we knowing that this is a repository, our brains kind of immediately go to CRUD. But if we look at the methods, they're named just a bit different. And while we could go a couple different directions with this, the point here is that symmetrically, we might want to make sure that, again, our names align. We saw this with the operator, connect and disconnect. So here we would want to stick with CRUD. So let's just make those names, you know, create, read, update, and delete, right? We can also look at parameters. We have nice parameters of ID here and there, but then we have something like update takes a task, but create takes the, you know, the raw values, right? So instead, we might be able to make this a bit more symmetrical by making sure that we're passing in task or ID more consistently. What's interesting here, and kind of to the point of Frake's talk, is that the symmetry also starts to hint at what methods in here are the write methods and what methods in here are the read methods. And that might help with something like event sourcing. It would allow us to determine, okay, that read or that find is actually going to perform a read operation. And it allows us to kind of make that distinctive in a way that we can make decisions about, you know, future architecture of the code. Another example I took from Kent Beck here, his implementation patterns, and just kind of adapted it to PHP. He has this nice little process thing, and I think this emphasizes the process of symmetry on multiple levels very well, so I wanted to use it again. But he has this process method for a job. And inside of it, we can really immediately see this oddball out, this asymmetrical line of code. And it's because its surroundings are basically abstracted into method calls, but right here we kind of see this low-level count plus plus. And it's not communicating what this is doing, right, compared to the other stuff. So we might abstract this into something like increment count. Oh, not going there, there we go. So we might abstract this into something like increment count. But again, even though now we've have the proper symmetry between abstractions, we don't really have the proper symmetry as far as kind of intent of the code or what the code's meaning to do. It's still a bit technical, right? We have good naming with process input, process output, but process increment count, that's, feels a bit wrong. So finally, we would land on something to his point like tally. And again, just like that operator example, we see things, process input, process tally, process output, it all reads very nicely and it communicates a bit more about what that is doing, right? The intent of that code. Okay, the final example here, still sticking with symmetry, but this one's going to tie kind of everything together to demonstrate how symmetry kind of permeates all the other practices, but also really creates this very positive feedback loop. Once you kind of start working on your code to make it more symmetrical, you'll start seeing so many other practices that can be applied. So let me demonstrate that here in this final little code demo. So what we have is this needs to run, and this comes from Frake's ODear app or ODear service. So this is something that we go into more detail on a YouTube video, but I'm just going to kind of brief through it here. So it's a pretty nice set of code here. It's pretty abstracted. It's readable on its own. So there's really, technically speaking, there's nothing wrong with this code. Of course it runs, but we can apply just a little bit of symmetry to it. So first of all, if we take a look at these return values, we see that they're a little bit mixed. The tone and kind of what's happening is changing. So sometimes we're returning false, then we're returning true, then we're returning false, then we're kind of returning an expression. So we're just kind of bouncing back and forth. And that can be difficult to track with a reader. So ideally, to make it easier on the reader, it would be nice to just have kind of all the false or negative paths up at the top, right? So we can do that first, just by applying a little symmetry. We'll take those false values and make sure they're all at the top. The next bit of symmetry we might be able to apply is the fact that these conditions are kind of a little all over the place, right? Sometimes they're chained methods, sometimes they're property access, sometimes they're negated. So the result of the top two conditions, we see this not sign. This middle one here, this check has already been scheduled or is running, while a little bit verbose in the name, is a nice little method that's called out. The next one is kind of a raw check, but it's also a compound statement as well, or compound conditional. And then finally, we take conditions and then we're passing them on to additional functions to have actions be performed. So they're just a bit all over the place. Again, nothing wrong with them. Clearly they work, but we can make them a bit more symmetrical by just ensuring that they're all the same tone and kind of the same abstraction level like we saw with Kent Beck's example. So we can remove that negation and just create a method called disabled. It's still going to access the property, but it gets rid of that relative complexity that we had before. We kept the already scheduled or is running. We just kind of shortened up the name to be symmetrical with the rest, dropping some of those prefixes for Boolean methods that aren't very common within Laravel. So again, symmetrical even with the framework now of kind of the way we named these methods. And then we kind of continue to apply that through the rest. Now notice I did leave this top one. As I talked about before, anytime I see something reaching multiple objects deep, that's just a smell. It feels to me like this isn't something that should be here. It's probably something a separate object should check before even calling this method. So I'm just going to pop that out. And so when we do, we see that now we basically have everything set up. And let's just kind of scroll through and see what this looks like symmetrically. And we see that we have all these nice methods, and we basically, if we do finally get to the bottom, we have a nice aptly named method instead of kind of that long chain as before, that we're just going to return this is ready to run or not. And that's basically symmetry, and that's everything. So let's go through these practices. Good, I'm perfect on time here. So we had formatting, dead code, nested code, using objects, big blocks, naming, removing comments, reasonable returns, rule of three, and symmetry, which is my personal favorite, but we kind of have to build up there as we saw. So I know that was a lot. There was a lot of code samples, a lot of back and forth. I think the slides jumped there a few times. But all of this is tightly wrapped up in my recent field guide or ebook, base code, where I have more practices that I cover, cover these in more detail with more code samples. We go in more depth. This is all in the digital swag. You get 20% off. So definitely check that out. If you want to take a look at that Oh Dear, as well as other refactors, there are videos freely available on YouTube. Check those out first. So I definitely encourage you to look at that symmetry refactor in more detail. I kind of ran through it quickly here in the interest of time. So I think I might have just a minute for a question or two if there are some, but I'm at Gone Dark on Twitter. So send me your questions there. I created a post in the speakers. I'm going to put some resources that I mentioned in here, all those packages and so forth for cleaning up your code. But there is the promotion for the base code field guide directly if you want.
All right, that was awesome. Yes, I'm glad you got that in. You also have in digital swag for your other products too. So Shift and
yeah, the video, excuse me, the Getting Git course, which I spoke on at the first.
Right.
There's some.
So everybody should definitely check that out. Get your code shifted. Get this book, which is, I mean, there's just so much stuff in there. Most of the feedback is just like people nodding their heads, like, oh, our code looks like that. Like, let's do one question though, because everybody loves this question. Where do you like to put these small classes, like a numbers.php or number range.php or money.php? Like, where do you organize that in a Laravel project?
Yeah, that's definitely like the largest question I get, and I actually spoke a little bit about that at Laracon with the Laravel by the numbers last summer. That's a post out on Medium if you want to check it out. But to answer the question, a lot of times what I'll see, a very common folder, at least initially, is just a services folder. So there's app services. And kind of like naming, I'll just end up kind of having that be a catch-all initially for a lot of things. And then over time, as I kind of determine, okay, well, I have like 4 things that are enums, I'll pull them out of services and maybe put them in like an enums folder. So I do kind of like this promotion process where I just have services be a catch-all, and if there's 2 or 3 things in there, I just live with it, right? Rule of 3 kind of thing. But once I have a couple, just like the models, I might go ahead and put them in their own very specific folder.
Yeah, I love that naming thing. I mean, I'm sure I'm like many other people out there, as you're referencing, that like you just get so caught up in the name. It's like I can't even do anything until I get this name perfect. And just to name it more technically and then let it evolve is interesting idea.
Yeah, you really have to let time play on your side. That's something for me. And again, I briefed over it, but use a thesaurus. Like just take, even if you take something like handler and you put it in thesaurus, you'll end up on all sorts of really great names like courier, and all sorts of operators in there. And you can just click through those until you kind of land on one that meets your domain, and then it's just going to feel great. But yeah, definitely don't get stuck on naming. Just keep coding.
Yeah, and all of us Laravel developers, we know Taylor's amazing talent for naming things. Unmatched, I feel like. He's the master.
Well, and borrow from it. If you see a good name within the framework, be symmetrical with it. If Taylor or Taylor and company is calling it a certain way, Laravel is calling it a certain way, call it the same in your app. There's no reason to be that unique snowflake.
Right. All right, man. Well, that's great. Thanks so much.
All right, well, I'll see you on chat. Thanks, everybody.
Yep. Okay.